Okay. So welcome to lesson 2 binomial expansion. My name is Hamted. This is MSM 112. So I'm going to start first by solving this question here, just for us to have a quick recap on what we did last semester. Oh, sorry, the last time we met. Okay, we just do this. Okay. All right. I think we can now proceed. So the question is expand a plus b if a is equal to 3/4 and b is equal to 1/4. Then find the value. And then find the value of the fourth term of the expansion. So the question first is saying expand this. Then when you expand this, find the value of the fourth term. So firstly, as I earlier on said, you identify which one is your A, your B, and your R and N. And according to us here, the value of A here is A. Yeah, the value of A here is A, and then the value of B is B, and then the N is 5 there. Then after identifying that, you can now start expanding your expansion. I know by this time maybe expanding this cannot be a problem, but let us go first. Let us see how we can find the fourth term of this expansion. So if you are finding the fourth term of this expansion, first let us, yeah, quite all right, you first have to expand this in full, but expanding this is not a problem, I'm sure. And then we move on to to finding the fourth term. So the fourth term, you can find the fourth term by identifying your n here is 5. So your n is 5, and then your r. How can you find r? Well, first let me write the whole formula here. So finding the nth term, the nth term is given by n, choose r, and then you have your a there, n minus r, and then you have your b, r, like that. So now to find your fourth term, you look at your n. Your n is 5 in this case. So your n is 5, and then your r. To find the r, you say r is equal to what term have we been told to find? We've been told to find the fourth term. So the fourth term, r is equal to the fourth term minus 1. That is going to be the value of r. So our value of r is going to be 3. So you put your 3 there, and then you do this. Then your a will still remain as a, and then your n minus r there. Your n minus r, your n is 5 minus 3, and then your b is still b, then your r is 3, like that. So you now simplify this. So this can be simplified by saying 5 over, so I'll write 3 factorial there, and then 5 minus 3, I'll get 2 factorial, and then 5 times 4 times 3 factorial, so that I cancel out this 3 factorial and that 3 factorial. So I'll remain with 2 factorial, which is just 2. 2 into 4, 2 into 2 is 1. Then 2 into 4, you get your answer to be 2. So 5 times 2, you get your coefficient to be 10. So our coefficient is 10 then. And then, having found the coefficient, we can now proceed here to finding what? So this is going to be 10. A, 5 minus 3, you get your A to the power 2, and then your B to the power 3. So when you reach this point, it's just a matter of simplifying and plugging in the values of A and B. So 10A, your A is, so your A, according to what you've been given here, your A is 3 over 4. You put your 3 over 4 there, and then you square it, and then you put your B there, which is 1 over 4, and then you raise it to power 3 like that. When you simplify this, you find your answer to be, so this is going to be your answer here, 45 over 512. So this is going to be the value of your fourth term. But initially, according to how this question is being phrased, you first have to expand this and then just pick out the fourth term, and you'll discover that your fourth term is going to be given by this formula here. So we proceed. So if you have any questions on what I'm teaching, please, you can raise your hand. There's an option of raising a hand there on your screen. You can raise your hand and then I'll point at you and then you ask. So tutorial sheet 1, let us also do one question from tutorial sheet 1, and this is question 7. So the question was saying, evaluate the coefficients of x to the power 4 and x to the power 5 in the expansion of x over 3 minus 3 to the power 7. Hence, evaluate the coefficient of x to the power 5 in the expansion of this times that. So here, the question is straightforward. It's asking us to find the coefficients of x to the power 4 and x to the power 5. And hence, we've been told to find the coefficient of x to the power 5 in the expansion of this. So this question might look by sight to be a little bit complicated, but it's straightforward. So how you work out such questions is you do what? You first have to get the coefficients of x to the power 4 and x to the power 5 in this expansion. And how do you do that? How can you just pick out x to the power 4 and x to the power 5 in the expansion of that? It's first by finding the value of r. So how do you find the value of r? First of all, you write your formula there. N choose r, and then your a there, your a to the power n minus r, and then your b r, like that. So your n choose r, you identify your n there. My n is 7. So this is 7, choose. What is the value of r? We don't know. It's the one that we're looking for. So mind you, after finding this is a. After finding this, you have to equate it to x to the power 4 in order to find your value of r at x to the power 4. And then you also come and equate it to x to the power 5 in order to find the value of r at x to the power 5. So the value of a there is x over 3. X over 3 is the value of a, and then your value of n minus r, it will still remain 7 minus r, and then you multiply by your b there is -3. Your b is -3. You raise it to the power r. And then we said you equate everything to x to the power 4. So here we're just interested in x. So meaning I'm just going to get out the x and then I'll leave all the constants, all the numbers. So I'm going to get x to the power 7 minus r. When you distribute this 7 minus r to everything there, you have x to the power 7 minus r alone. You get it like that, and then you equate it to x to the power 4. And then since the bases are equal, meaning even the powers are also equal, so I'll say 7 minus r is equal to x to the power, it's going to be equal to to 4. So when you bring this 4 this side to be 7 minus 4, and then you take this r, this other side, you have your r. So 7 minus 4, you find that your r is nothing but 3. So if your r is 3, you can now find the term in, or the coefficients in x to the power 4. And how do you do that? It's by replacing this r there in this expression. So I'm going to say 7 choose 3, 7 choose 3, and then your a there is x over 3, and then you say 7 minus 3, you get your 4 there, and then multiply everything by negative 3 to the power r, which is 3. So what am I going to get after this? So I'm going to get 7 choose 3. We all know how to evaluate this by this time. It's just, so 7 choose 3 is just 7 times 7 times 6 times 5 times 4 factorial. Then everything divided by everything divided by 7 minus 3, you get your 4 factorial there. And then you write your 3 factorial down like that. So your 3 factorial is just the same as 3 times 2 times 1. 3 times 2 times 1. But even if I've put the 1 this side, there's no problem. 3 times 2 times 1. Since multiplication is commutative. So you do that, you cancel that. Then you start dividing. Oh, before I even start canceling, I should first calculate what is 3 to the power 4. 3 to the power 4, it should be 81. So 3 to the power 4 is 81. Okay. 3 to the power 4 is 81. So I'm putting this in brackets. It's 81. Then this is going to be like this. And then on top here we have x to the power 4. Like that. Then you write 3 to the power 3, you get negative 3 to the power 3, you get negative 0.7. Like that. Then when you simplify everything here, you discover that your answer will be this 2, 1, and then this 2 there will get 3, Then this 3 and that 3 cancels. So meaning we're remaining with 7 times 5, which is 35. So we're going to get, then when you multiply 35 times 35 times 27, you get negative 945, and then you divide that by 81. You get your answer to be 35 over 3. So your answer here will be negative 35 over 3, then everything over 3. Sorry, everything here multiplied to the power, multiplied by x to the power 4. This is what we are going to get. So the process is a little bit longer. It might end up consuming most of our time. So let me just show you how I did it. You can see there. First, you find that you expand. You first find what I'm just from doing here. This is what I found here, negative 35 over 3. You also find the term that has x to the power 5, which I found to be 7x to the power 5 plus 9. So when you expand this, just getting these two terms, this is what we're going to have. Then from there, you multiply this times that. So you multiplying this times that, you're going to multiply this times that. So you multiplying this and that simply means that you are just multiplying this x plus 6 times what you found here. So this is what I did here. I multiplied the 2. And then in this multiplication that I'm going to get, the question here is saying I should only find the coefficients of x to the power 5. So meaning when I multiply this, I'm just going to be getting the coefficients of the terms that are going to give me x to the power 5. Then when you multiply this, for instance, let me just do this. When you multiply this, negative 35, x to the power 4 over 3 times x. When you multiply these two, you get negative 35 over 3 times x to the power 5. When you multiply this x times that, you get that. And then when you multiply this 6 times that, 6 times negative 35 over 3, you get something like 70, negative 70 x to the power 4. You get something like this, x to the power 4. Then try to multiply this, x times the 7x to the power 5 over 9. You get positive 7 over 9, 7 over 9, and then multiply by x to the power 6 when you multiply these two. And then when you multiply 6 times that, you will get something like 42 over 9 x to the power 5. So this is what we're going to get. But the question here is saying you just get the coefficients of x to the power 5. That's what the question is asking us to do. In the multiplication of this, you just get the coefficient of x to the power 5. So how do you do that? You just get these terms having x to the power 5 and add their coefficients. Yeah, and add their coefficients. So you're going to have negative 35 over 3. This one is x to the power 4, so you leave it. And then this one is x to the power 6, you leave it. And then you also get 42. So this is going to be 42 over 9. So this is what I was just trying to explain here. Then when you add the 2, you discover that your answer is going to give you this. So don't look at this 42 to the power 5 be something very complicated since it's not here. I just reduced this 42 over 5 into 14 over 3. There's a number that can go into 43 and 42 and 9 without leaving a remainder. And I think that is the 3. When you divide the 9 by 3, you get 3. You divide 42 by 3, you get 14. So I just reduced it here. Then when you add the 2, you get your answer to be 7x. And since the question is saying find the coefficient, meaning you are just getting this 7 here as your answer. Hope we are moving together. So we have another example there. Use the binomial series to determine the expansion of 2 plus x to the power 7. So this one is also straightforward. You first have to write your formula. Let me just, okay. You first have to write your formula there for the binomial expansion, which is n choose r, and then your a, n minus r, then your b, and then r. Then you begin to identify which one is your n, which one is your r, and then which one is your a, and then which one is your b. But of course, this one is asking us to expand it. So meaning we're going to have this repeating itself a number of times. So how do we go about this question? Simple. You write it first like that, 2 plus x. Then you have to the power 7. And of course, the first term there will be 2 raised to power 7. Yeah, and then the second term there will be, this will be n, which is your 7. 7 choose 1. Sorry, this is not supposed to be 7 choose 1. And then you write your 2 there, will reduce, and then your x will be introduced there. Then plus 7 choose 2. So you go on like that. Your 2 there will reduce in power, and then your x there will increase in power by 1. Then plus 7 choose 3. And then your 2 there will reduce. You have a 4. And then x to the power 3. So you go on like that until you reach a point where you're just going to have x to the power 7. That is how you expand such an expression. So it is just as simple as this. So this is the solution here. Is the solution. So we know to say 7 choose 1 is just the same as 7. This 2 here has reduced in power, the 2 there is reducing, the x is increasing. So that is what I was talking about. And of course, this is just 7 choose 7, which is just the same as 1. And then you have your last term as x to the power 7, like that. So it is as simple as that. You can try it on your spare time or the time you're going to be studying. You can try to work it out. Let's proceed. So this is going to be your answer. When you expand everything there, this is going to be your answer. So we move on now to the next part of the binomial theorem, which is the last part. Once we do this, if we're going to manage to finish it today, then we're going to be done with binomial today. So that next week we'll quickly start trigonometry. And then if by God's willing, maybe we can even start complex numbers if we're going to manage to do that. Okay. Maybe just, okay. All right. People are still coming in. All right, so we start the extension of binomial theorem. So the extension of binomial theorem is this one here. So it's derived from the binomial formula. So the extension is derived from the binomial formula, and this is the formula here. So in this formula, when the value of a, so in the formula, when the value of a is equal to 1, you use what we call the extension. So try to expand this when the value of a is equal to 1. You're going to get something like this. This is what you're going to get here. When the value of a is equal to 1, you're going to get this. The first term there, which is a, will be raised to power n, and then 1 to the power any number, you still get the same 1, and then plus the n, which is 1, oh sorry, the n there, which is n, and then you multiply it by x, you go on like that, n minus 1, x to the power 2. Yeah, so this is useful and very important. This extension is helpful, and it can be used to expand almost all binomial expressions. It's very important. You need to know it by heart. Yeah. So we move on. So this, when you look at this extension here, it's valid when the absolute value of x. So this is only valid when the absolute value of x is less than 1. This one here. It's straightforward and it's not difficult to master. When the absolute value of x is less than 1, that's the only time when it's valid. And this is going to be -1. In other words, you can write this as -1 less x less +1. So this is what you're going to have. And in other ways, you can also write it as -1, comma 1 in set notation. We move on. So this is just what I was talking about. When x is small compared with 1, then x plus 1 to the power n is just it's just equal to 1 plus nx. Yeah, so this is what I was talking about here. We proceed. So when n is a fraction, yeah, so this, what we're going to start learning again here is the uses of the extension. So there are some binomial expansions that we're going to meet. Some of them you find them to be in this format. Maybe here there's a and then plus x, and then you have something, maybe a negative number here as your value of n. Or if not that, you find another expansion which is something like this, which is in this format. Then the value of n there, the power, you find it, maybe it's half. It's a fraction. So when the value of n is a fraction, or the value of n is a negative integer, you are going to have the extension as the only way to expand that expression. So this is what this statement here is saying. When n is a fraction or a negative integer, you always have to use the extension. So it's very useful. It's very important. You need to know it. So that is the extension there. So if this n here is negative or a fraction, you always have to use this. So if, for instance, maybe here where there's always supposed to be 1, there's a number or any variable x or y, you always have to find means to make it 1. Here, there's always supposed to be 1. You can't use this if there's no 1 here. We proceed. So we move on now to see how you can use this extension. So here is an example. Evaluate 1 plus 1.002 to the power 9. This is the question here. You've been told to evaluate this using the binomial extension. So this is one way in which the extension works. So how you go about with such a question is like this. So you look at this question here. This is 1 plus, oh sorry, this is 1 point. This is 1.002. So please, if you have any questions, feel free to ask. This is 1.002 to the power 9. So this expression here okay, so this expression here can also be written as 1 plus 0.002 and then everything raised to power 9. So when you look at this, when you add this, you still go back to that. When you add this, you still go back to that. So now, since we have 1 here, we have at least qualified to use this, because this we have a 1 there, and then our value of x in this form, in this case, we're going to have 0.002 as our x. So let's proceed. So now, how do you expand such an expression? Firstly, the first term is always 1. So I'll write 1 there. And then I'll say plus. My n of course is 9. My n is 9, which is the power. Then I'll multiply this n with the x now, which I have there. So firstly, my x is equal to 0.002. And then the value of n that I have is 9. So 0.002 is the value of x that I have. So I'm going to put it there, 0.002, like that. That is the value of x. And then I'll keep on moving, plus 1, what is my n there? My n is 9. And then I'll open my brackets. So n minus 1 is just the same as 9, since n is 9. So n minus 1 is 9 minus 1, which is 8. I'll write my 8 there. Then close the brackets. And then my x, what is my x? My x now has to be raised to power 2. So my x is 0.002, like that. So with such questions, and then raised to power 2, with such questions, you have to go back to grade 1 types of methods of multiplying decimal numbers. So this is 2 factorial. So 2 factorial is just the same as 2 times 1. So you keep on going like that. But in such questions, if you know that you don't have time, more especially in the exam room, and maybe the accuracy of your answer is not specified, what you do is you just end on the on the third term. You don't go further than the third term, because you can spend the whole 3 hours in your exam room just answering one question. So you just end on the third term, but you still find the same answer, or rather the answer that is going to be similar to the normal answer. When you punch this on your calculator, 1.002 to the power 9, it's going to be almost the same. So as you keep on expanding, the more you expand it, the more the accuracy. That's the way this question is. So now you move on, you continue. So 1 plus, so you multiply 9 times 0.002, you get 18. 18, and then how many decimal places do you have this side? It's 1, 2, and 3. You have 3 decimal places, so you move 1, 2, 3, like that. So you have your point there, and then you have your 0 there, and then another 0 there. This is how you calculate decimal numbers. This is how you multiply them. So we move on, and then you say plus. So you divide this 2 into 2, 1, and then 2 into 8, you are going to have 4. Then 4 times 9, that is going to give you now 36. 4 times 9 is going to give you 36. And then 36 now, you have to multiply this 0.002 times 0.002. So I said you have to go back to the grade 1 ways of multiplying decimal numbers. So you say 0.002 times 0.002, you get first your 4 there. Then when you get your 4, you start now, you count how many decimal places do you have? 1, 2, let me just write it here. 0.002 times 0.002. So when multiplying this, you first have to count your decimal places that you have. So this is going to be 1, 2, 3. You have 3 this side, plus this side 3, 4, 5, 6. So you move 6 steps starting from here. You move 1, 2, 3, 4, 5, 6. You just have to go back to your grade 1 way of solving this. So you put zeros there. 1, 2, 3, 4, 5. So this is what you're going to have as your answer. You just have to go back. You need to revise. Then from there, you have now to multiply that 36 times 0.0000. Yeah. So this is what we're going to have here. So this is going to be 1. So 1 plus 0.018, you get 1.018, like that. And then plus, you multiply 36 times 4. Again, you go back here. So you're just going to say 36 multiplied by, also 36 multiplied by 4. So it's going to be 36 multiplied by 4. You do that. 4 times 6, you get your 24. So you write 4 there. Remainder 2. 4 times 3, you get 12 plus 2, you get 14. You just have to go back. It's interesting. All right. So now you count the decimal places that you have here. So you have 1, 2, 3, 4, 5, 6. So you have 6 decimal places. So if you have 6 decimal places, you also have to move 6 times 6 points this side. 1, 2, 3, 4, 5, 6. So you're going to have your point there and then your 0 there. 1, 2, 3. So I'm going to have 0.00001, 4, and then 4. So when you add the 2 now, you get something like, you put the decimal numbers in the same line. So you're going to get, let me just do this. Okay, I'll put the decimal point here in the same line. So I'll add 1.018. So now you start adding 0. So where there is nothing yet, you just replace with what? With zeros. So 0 plus 4, you get your 4. 4 plus 0 there, you get your other 4. 1 plus 0, you get your 1. 0 plus 1, you get your 1. 0 plus 0, you get your 0. Then this point, you put it there, and then 1, you put it there. Sorry, forgotten something here. 1 is there, 0 plus 8, there's supposed to be 8 here. Okay. So this is going to be your final answer, which is going to be 1.01814 and 4. So this is going to be your answer. This is going to be your answer. Since the accuracy has not been specified, you can leave it like this. There's no problem. Whew. This question, you just have to visit your grade 1 way of multiplication. All right, we proceed. So this is how you're going to do it. This is what we did. Okay, so you identify your x and your n there. Then you multiply them like that. You find your answers like that. And then that is going to be your answer as your final answer. Okay, let's proceed. Another question here. This is a question from your tutorial sheet. So I'll show you how to go about with these questions, but maybe 1 or 2, I'll not finish them up. It's going to be your exercise. You're going to finish them up. Then you have to be submitting these exercises because I have to be knowing whether you're understanding or not. You can solve and then send a picture on WhatsApp. Then I'll tell you where I went wrong or if you have gotten it correct. Same applies to the previous exercise I gave you. So first of all, we'll start with this same one here, which is 0.98. So 0.98 to the power 7. And then this has, since we know that we are supposed to use this extension, so meaning we have to express this in this form. We have to express 0.98 to the power 7 in the form which is 1 plus x to the power n. And that is it. You have to, this is how you can express it here. So 0.98 can also be written as 1 minus 0.02. So meaning you now need to identify which one is your x and then which one is your n. Of course, our n there is 7, and then our x you get together with the negative. It's negative 0.02. Yeah, that's it. Then you put them in the formula. You begin to expand like that. Expand them in that way. Then 1 minus 0.14 plus 0.008 is going to be your answer when you simplify them. So that is going to be your final answer after simplifying the question. Hope we are following. If you have any questions, please, you can ask. So move on to the second question there. The second question, you can also write this 1.003 to the power 5 in that form. Then you identify your n, which is 5, and then you also identify your x, which is 0.003 to the power 5. Oh, sorry, your x is just 0.003. Then you use your formula there to expand it. And then after the expansion, that is going to be your answer. Move on to the last part there, which is that on this one, you have to pay attentive. This one, pay attentive. This one, a lot of people miss this question. So for this question, after expressing it in this form, I'll take my time to explain this because it's very helpful here and even maybe in the slides to come. So this 2 plus 0.01, we have seen to say this, we can't expand this using the extension because the extension, the format is supposed to be 1 plus x to the power n for the extension to work. look at these two here. These two and this one are different. One is not equal to 2. So I mean the extension cannot be applied here. So what do we do now? If the extension, if the value of A is not equal to 1, what do we do? We have to find means by which we're going to make these two to be 1. And how can we do that? So I'm going to open these square brackets like that, and then I'm going to open the square brackets, and then I'll factor out the 2. These two, I'll factorize the 2 or factor out the 2. It still means the same. I'll do this. So what I mean by factoring out the 2 is by dividing everything by 2. So I'm going to divide everything there by 2. So 0.01 divided by 2, like that. And then I'll put this power outside. This power applies to everything, the 2 and the 0.01. That's the reason why I'll put it outside. And then from there, we can simplify this now. 2 into 2, you get your, so 2 into 2, you get 1 there. We now have our 1. And then plus, when you divide the 0.01, when you divide 0.01 by 2, you get your answer to be 0.005. You get your answer to be 0.005. But remember, we still have this 9 outside. We still have the 9 outside like that. So from there, what you do is you distribute the power. So this power applies to the 9, applies to the 2 and also to what is in the brackets like that. 0.005. So this is what happens. Okay. From now, I think it's even easier because we've attained what we wanted here. We've achieved our format. Now, remember there is this 2 to the power 9 outside, and then we know that 2 to the power 9 is nothing but 512. So 2 to the power 9 is nothing but 512. So I'm going to write 512 here. 512. And then I'll do this plus 0.005. All right. To the power 9. From here now, since we have achieved our format here, so we now need to identify which one is our x and which one is our n. Of course, our n there is going to be 9, and then our x is going to be 0.005. This is going to be our x, and then this is going to be our n. So after that, we can now expand this. So it is after expanding this part here that we are going to multiply it with 512. So of course, you remember what I said. You don't have to expand everything here. You just have to end on the third term. So we're going to have 512 outside like that. 512, and then you open these square brackets, and then you say the first term is going to be 1. The second term is going to be nx. Nx, we're following our extension. Our extension is 1 plus nx, and then plus n, and then open brackets, n minus 1, and then x squared over 2 factorial. And then you keep on going like that. So remember what I said, the more you expand it, the more accurate you become. So if you want, you can be going up to the 4th term. It's up to you. But me, personally, I like just ending at the 3rd term. So 512 times 1 plus, so our next term here will be nx. So my n is 9, and then my x is 0.005, like that. And then you do that. And then plus my n is 9. And then n minus 1, 9 minus 1, I'll get my 8 there. And then my x will still be the same one, 0 0.005. And then open brackets and close to the power 2. And then everything over 2 factorial, which is just 2 times 1. Then we go on like that. Let me just see the messages here. I've seen there are 2 messages. Is it fine to start solving without writing the formula? No. Okay, yeah, somehow you can start solving without writing the formula, but again, it depends with, it depends with, it depends with the person who is going to be marking you, but the formula is very important because you starting to write the question without writing the formula, it seems like you're just guessing, or maybe you're just copying from someone. But when you write the formula, you are trying to show your marker to say, I know what I'm doing. And then the second question is saying, let me see first. All right, no problem, Adeline. I've seen your question. No problem. Okay, we proceed. So you just end on the third term, like that. Okay. Then from there, you can now simplify everything. There are 5, 12. Remember what I was doing there, going back to grade 1 weight. You simplify everything, 1 plus, you multiply that, and that. Yeah, you find your answers to be, okay, let me just delete everything here. You find, this is what we've been doing. Yeah, so 2 plus 1, you factor out the 2, like that, you divide everything, and then, sorry, there was a mistake here. This is not supposed to be 29. It's supposed to be 2 to the power 9. This is supposed to be 2 to the power 9. So before distributing the slide, I'm going to write it properly. So that's, you use the formula that, and then you expand it in that way. Then you're going to find your answers that. So when you're practicing, make sure that you calculate it properly, and you should also be fast when calculating, because these my decimal points are the ones that normally consume most of the time in your exams. So you just have to know, you just have to be practicing, yeah, for you to increase your speed. So we move on to this question here. So this question, this is question 8 from tutorial sheet 1. This is question 8 from tutorial sheet 1. So you also have to work it out the same way we've been doing these previous questions. Since we know that there's a 1 here, it simply means that there's high chance for us to use there's high chance for us to use the extension formula of binomial theorem. So what you can do to simplify things here, you can say let this, you can say let, in this question, you can say let my x plus bx, let my x plus bx squared be equal to a. So what you're going to have is 1 plus x, oh sorry, not 1 plus x, we're going to have we're going to have 1 plus a, while there's x plus bx squared, you replace with a, you're going to have 1 plus a to the power n is equal to, we've been given that the first 3 terms in the expansion of this is that, so this is equal to 1 plus 7x, and then plus 14x squared. So this is what we're going to have. So what this means is that you're going to expand this part to this side, and then you equate the corresponding terms on the right side. You equate them to the corresponding terms on the right side. So how do you expand this? You are going to expand this up to the third term. So remember, if the value of a here, the first term here in the expression is 1, we can use the extension. So I'm going to expand this. So meaning my first term there will be 1, and then plus my n there. What is my x? My x in this case is a. And then plus n, and then open brackets, n minus 1. Since I've not been given n, so I'll just be writing n like that. Then over 2 factorial, which is just the same as 2 times 1. But 2 times 1, we know that it will still give us 2. And then my x there is a, and then now this time around it will be squared. So this is what you get. So now, having gotten this, we can now recall that our a is x plus bx squared. So while there is a in this formula, I'm going to put x plus bx squared. But I know that all this is equal to 1 plus 7x plus 14x squared. So now, this is going to be like this. While there's a, I'm going to put x plus bx squared. So this is going to be n x plus bx squared, like that. And then plus, I'll still leave my n, and then n minus 1, then everything over 2. But my a there will still be my a there will still be that which is x plus bx squared, like that. And then everything is squared. So this is equal to 1 plus 7x plus 14x squared. So this is how it's going to be. So 1 there is equal to 1. And then this part here is equal to that part. Then that part